Hello everyone! In this video we're going to be doing two examples of tracing programs that have pass-by reference functions in them. We'll go ahead and just start right off. This is our first one. We have a function f that we can see takes in two parameters, pointer a and pointer b. So we know that these values that are going to become local variables in f do not store integers, but addresses to where integers are located in memory. So when we're tracing a program that has functions, remember we always start in the main function. It's because C is a compiled language, and main is the only function that's automatically called by the compiler. At the top of main, we're declaring three variables. It's A, B, and C, and we're giving them initial values 1, 2, and 3. Then we're assigning B the value that is returned from f, where f is given as parameters the address of A and the address of C. So inside function f, we have A, which is a pointer, and A points to A from main, because this pointer A is given the value, the address of A in main. So A points at A. A local variable B, which is a pointer, is given the address of C from main. So it points at C from the main function. So this is A inside function f, and this is B inside function f, and they point to those variables in main because they're pointers, and they've been assigned those addresses from the function call. So now we're executing inside f, and we're saying go to where A is pointing and assign it the value of what A is pointing at times 5. So we're going to go to where A is pointing, and A is pointing at A from main. So take this value, multiply it by 5, so 1 times 5 is 5, and store it where A is pointing. So we're going to go to where A is pointing, and A is pointing at A in main, and change that value to 5. Then we're going to go to where B is pointing and assign it the value of what B is pointing at plus what A is pointing at. So again, A is pointing at A, so that's 5. B is pointing at C, which is 3. So if we add those two together, we'll get 8. And we're going to store it where B is pointing, which is at C. So we're going to go into memory and change the value that C has to 8. And then we have a print statement. So this will be our first occasion for output. And we're going to print what A is pointing at and what B is pointing at. So A is pointing at A in main, B is pointing at C in main, so we'll see 5 and 8. And then we have a return statement that returns the value of what A is pointing at plus 4. So we'll evaluate that first. A is pointing at A in main, which has 5. If we add 4 to that, we'll get 9. So we're going to return 9 to this location, which means B will be equal to 9. Now that we've returned, we're back in main, and we're going to print the values of A, B, and C as they are in the main function, which is 5, 9, and 8. So that's a quick example of how pass-by-reference functions can be traced. Remember, in a pass-by-reference function, any changes we make at the memory level with pointers or arrays are also going to be evident in the main function. Remember, one of the cool things about tracing programs is after we've traced them and we have an output that we believe is correct, we can double check that using the compiler. So here's the same code in the IDE, and if we run it, we should see, if we were right, the same values that we calculated for our output. And they're the same, so we traced that one correctly. So we have a second problem that we're going to do, and this one is a little bit more complex. This one comes from your textbook. And it mixes parameters types in the functions. So in function 1, f1, a is a pointer, and b is not. And in function 2, a is not a pointer, but b is. So that's going to complicate our tracing a little bit. But like always, we'll start in main. At the very beginning of main, we create 4 variables, a, b, c, and d, with initial values 5, 2, 7, and 9. We're going to have 4 function calls and 4 print statements in main. Each of our functions also has a print statement, so we're expecting to see 8 lines of output. We'll start off with the first one. Here's our very first function call. Remember, we execute sequentially. So C is going to be assigned the value that's returned from function 1, where function 1 is given parameters the address of D and the value of A. So F1 has local parameters. A inside F1 is a pointer, so it's given an address. So it's given the address of D, so it points to D in main. But B is not a pointer, it's an integer, so it's just going to take on the value. So we're going to use an equal sign instead. And it takes the value of A, which is 5. So that will pass control to F1, where A points at D in main and B is equal to 5. So we're going to go to where A is pointing and assign it the value of B minus 8. 5 minus 8 is -3. So we're going to go to where A is pointing and put a -3 there. Then we're going to say B should be assigned the value B times 2 minus what A is pointing at. So B is 5. 5 times 2 is 10. Minus -3 is 13. So B will have the value 13. And then we'll print them out. We're going to print out what A is pointing at and the value of B. So A is pointing at D. D is -3, so if we print out what A is pointing at, we'll print -3. And B is equal to 13. Then we're going to return B minus what A is pointing at. So B is 13. Subtract what A is pointing at. A is pointing at D, which is -3. So 13 minus -3 is 16. And we're going to return that value here. So C will be equal to 16. Then we have our first print statement in main, which prints out the values of A, B, C, and D as they are in main. So A is 5, B is 2, but C and D have both changed. Now this is a very complex example. It's easy to get mixed up. So we're going to go ahead and check it right here. But we don't want to see the other answers too early, so we're just going to look at these first two that we've already calculated and make sure that the first two lines of output from the code match the first two lines of output that we derived. So far, so good. Our next part has A being assigned the value that's returned from function 2. If function 2 is given the parameters c minus d and the address of A. So that function call, A is an integer, and it takes the value c minus d. So 16 minus negative 3 is 19. This is A in F2. This is B in F2. B is a pointer. See the formal parameter down here, integer pointer B. B is a pointer, so it's going to take the address of A, so it will point at A in main. So now we're executing inside function 2, and we said A should be assigned the value of what B is pointing at plus A. So B is pointing at A in main, which is 5. If we add that to A, we should get 24. And then go to where B is pointing and assign that the value of 37 minus what B is currently pointing at. So B is pointing at A. A is 5. 37 minus 5 is 32. So store that where B is pointing, which is at A in main. So now A is equal to 32. And we're going to print the value of A and what B is pointing at inside our function. So A is 24. B is pointing at A in main, which is now 32. And we're going to return the value of A. And remember, we're going to return that right here. So A in main is being assigned a new value, which is the returned value from F2, which is 24. This is a good reminder about the order of execution. A is being assigned the result of this expression, because that's how assignment statements work. This expression changes the value of A a couple of times, but this is the most recent execution. A is assigned whatever is returned by this function. So regardless of what happens to A in F2, when we return 24, A then becomes equal to 24. And then we print the values of A, B, C, and D in main. And we're going to double check to make sure that we're continuing to get the right answers. So we'll run the program. We'll get the compiler's answers and compare it to ours and see that we are still on the right track. So we'll do our next segment. B is assigned the value that's returned from F1 when F1 is given parameters the address of C and the value 8. So we'll return to F1, and A is going to be pointing at C in main, and B in F is going to take on the value 8. Now we're going to run the code inside function F1 again. So we'll say go to where A is pointing, put B minus 8 there. Since B is equal to 8, that's going to be 0. So go to where A is pointing and put a 0 there. Then assign B the value of B times 2 minus what A is pointing at. So B times 2 is 16 minus what A is pointing at. A is pointing at 0. So this will be just 16. Then print what A is pointing at and the value of B. A is pointing at C in main, which is now equal to 0, and B is equal to 16. And then return B minus what A is pointing at, so 16 minus 0. We're going to return 16, and we're going to return it to this location. So B is assigned to the value 16. And we'll print those in main. And then we'll check them using the compiler. One more segment to go. We're going to do this one here, where D is assigned the value returned from F2, when F2 is given the parameters the value of B and the address of A. So the value of B is 16, and the address of A is going to be to A in main. And A is going to take on the value of what B is pointing at plus A. So we need to add the two of them together. So A from main is 24, plus 16 is 40. So A's value will change to 40 because of this assignment statement. Then we're going to go to what B is pointing at and do 37 minus what B is pointing at. So B is pointing at A in main, which is 24. So we're going to do 37 minus 24, which is 13. So we're going to go to where B is pointing and put 13 there. Then we're going to print the value of A and what B is pointing at. So remember, A inside our function is 40, B is pointing at A, and A is now 13. And then we're going to return just the value of A. Remember, A is 40. We're going to return that value here. So D is being assigned 40. And when we do our last print statement, we'll print these values as they appear in main. So these guys. And then we'll do a final check to make sure that all of our output matches the output that comes from the compiler. And since our outputs match, we've traced this particular example correctly. So that's it for our tracing examples. I hope you found them helpful. And I would encourage you to continue to do tracing programs on your own to make sure you're well prepared for debugging and logically following the process of pointers, because changing things at the memory level is necessary, but it can also be kind of confusing. So please do practice programs and let me know if you have any questions. In our next chapter, we'll be talking about strings, which are a special form of character array, and we know that arrays are also references. So pass by reference functions are going to be sticking with us for a long time. I'll see you then.